Okay, so this is a practice problem pertaining to circular motion, and as you can see at the top, I've written a couple of formulas up here. So the first one is a equals 4 pi squared times r all over t squared. And the a stands for acceleration, the capital R is radius, and then the capital T on the bottom means period. It's also kind of in the case of circular motion, it's kind of a substitute for time in this case, as we'll see in the problem. Acceleration can also equal v squared over r. In this case, the v means velocity and r still means radius. And another formula that we'll be using is average velocity equals distance over time, which is the same thing as 2 pi r, so 2 pi radius over t, period. And another one that we'll be using is F net, or also known as the net force, equals mass times acceleration. So all of those will be employed in the following problem. So the question is, a 95 kilogram player makes a turn on the football field. His path is a portion of a circle with a 12-meter radius. He makes a quarter of a turn around the circle in 2.1 seconds. Find the speed, acceleration, and net force acting on the player. So I've kind of drawn it here. His turn is a quarter of a circle, so he's only going this far. He's not going all the way around, he's just turning a corner. The radius is the distance from the center point to the very edge of the circle, and then it takes him 2.1 seconds to make that quarter turn. So first off, we're going to find the average velocity, and we're going to use this equation up here, plugging in our radius and t value. And it doesn't explicitly say period in the problem, but in this case, the same thing. He makes a quarter of a turn around the circle in 2.1 seconds. In this case, we're substituting that 2.1 seconds for the period because period is a function of time. So the average velocity in this case, we're going to be multiplying by 1/4 because he's only turning a quarter of the circle, not the whole thing. So, and 2 pi r is really just circumference of a circle. So we're only taking a quarter of that circle, not the whole thing. So in order to find average velocity, it's going to be 1/4 or 0.25 times 2 times pi times the radius all over t, the period. And that's going to change to 1/4 times 2 pi times 12 meters over 2.1 seconds. And because of the units, because of this meters and the seconds, our final units are going to be meters per second. And that's going to roughly come out to, with a little bit of rounding, 8.98 meters per second. And now, since we have our velocity, we can solve for acceleration using this problem from up here. You could also use this one as well if you wanted to, but since we've already solved for velocity and this has a fewer components, this might be a bit easier to use in this case. So acceleration equals velocity squared over radius. So we're taking our answer from this part of the equation, or this part of the problem. So it's going to be 8.98 meters per second squared over 12 meters. And that roughly comes out to 6.71 meters per second. And the reason it's meters per second squared is because this unit up top is getting squared. And so finally we're going to find the net force. In order to do that, you're doing mass times acceleration. So we're going to be taking the acceleration from up here and the mass from up here. So the mass is 95 kilograms and the acceleration is 9.71 meters per second squared. And when you multiply those two together, you're going to get 637.83 newtons. And these two together, this kilograms and this meters per second squared, when you multiply them together, that's when you get newtons. So that's the three final answers to the solution. And doing them in order makes it so that you can plug in values from your previous answer to get your next answer. So it's good if you do them in a proper order.